An automated door lock system is a prime example of mechatronic system which combines mechanical, electronic, and computer engineering principles to create a complex system. This integration allows for the design and development of a system that can control locking and unlocking of doors automatically. The mechanical components include the lock mechanism, door handles and hinges, while electronic component consists of sensors, microcontrollers, and actuators. Additionally, software and communication protocols enable remote control and monitoring of the system. By combining these engineering disciplines, an automated door lock system exemplifies the essence of mechatronics. The problem statement is the existing automated door lock system face various challenges that hinder their reliable and secure operation. Technical malfunctions, security risks, compatibility issues, false positive, maintenance requirements, vulnerability during power outages, and high cost pose significant obstacles to the widespread adoption and effective functionality of these systems. First objective of the project is to enable employees to access the building and their designated rooms conveniently using keyless entry. Second, consider cost-effective solutions for hardware, software, and installation, ensuring that the benefits of the automated door lock system outweigh the associated expenses. And lastly, design and deploy a robust and reliable automated door lock system that minimizes technical malfunctions, ensuring smooth operation and minimizing the downtime.
I'm going to present the block diagram for our project. Our project has the one input and two output. The input is ultrasonic sensor, output is the NORAD UI, and the big LED indicate the door. The microcontroller we use in our project is the Arduino Wemos D1, which is the Arduino-based Wi-Fi and can send the data, the input from the ultrasonic sensor and then send to the cloud. The public cloud we use is the HiveMQ cloud. Then you send the data through the NORAD. Then the NORAD also can send back the data to the Arduino through the HiveMQ cloud. Then Arduino will send signal to the LED to light out, then indicate the door is open, is unlocked or not. The coding we first write in the Arduino IDE software. In the IDE, we first declare the input output and also the topic that we use to cover the data to the public cloud. Then this coding will be implemented in the Wemos D1 to run the simulation. The public broker that we use is the HiveMQ. HiveMQ is the open source and free. The setup for our UI is done in the NORAD. NORAD is a browser-based flow editor that uses a wire to connect all the nodes, and every node has their function related. And from the first two is for the get the data from the Arduino to the public cloud. At the right side, that it will be deploy the data into the I and the NORAD. The third one is the switch that we use in the UI that we control from the NORAD UI to the Arduino. Here is the view of our project UI. Then we also have the browser. Open the browser, then it will be react simultaneously with our hardware.
So this is the modeling design for the door lock system. So the design is in the office. Yeah, so this is the entire door lock system in the office. So our electronic part you can see is at the side door, yeah, which consists of the microcontroller and the door lock actuator. And this is the outside of the door. Yep, so this is the our entire design for the office.
This is our project overall workflow chart. So first we will do some literature review on the automatic door lock circuit design for the previous circuit design. So after we do some research, we will start to write the source code for the system, for the circuit system. And then after we complete writing the source code, we'll verify the source code whether whether source code is running good or there's some syntax error. When the source code is verified and is correct, then we'll start to design the automatic door lock circuit by using the Proteus design cert. Later, we'll simulate the circuit's design with the source code imported to see the simulation result. So when the simulation result meet our specification, we'll proceed to the hardware circuit constructing process by combining all the circuit components to build the circuit, and then we'll test the circuit by importing the source code into the Arduino board. When the circuit system is validated and is okay to run, then we'll start to build the UI system by using the Node-RED software, which is by writing the source code, another source code to build up the UI user interface system. So when the source code for the UI is complete, then we'll start to testing the UI system by connecting to the circuit wirelessly to test for the IoT function, and to check the validation of the system and the software to check for the IoT performance. So when the UI setup is complete success, then we just observe the system hardware performance and also the UI to check for the IoT and check for the data store. So after all the observation, we will just analyze the result and we write all the observation and result analyzed into the report. And yeah, that's all for our overall general workflow chart.
Now I'm going to demonstrate the hardware simulation of our project. The feature of our project is that we design an IoT UI dashboard at the Node-RED platform. As we can see in the screen that we designed the dashboard. The microcontroller for our use is the Remote D1, which is the Arduino that can connect to the Wi-Fi. The input is the ultrasonic sensor. The output is the LED that indicate the door. That when the LED is light up means that the door is open, and then in dim the door is closed. From the UI that we have the object detection that shows that the object that's sent then received from the ultrasonic sensor, then in how many cm distance apart. The second part is the door status that we can see that the door is open or closed, that it will be green or red. And then the third part is the PC control that we can control the door open or closed at the dashboard from the PC. The distance we set that the ultrasonic can open the door is less than 6 cm or 76 cm. Then when the object is detected less than 6 cm and 4 cm as shown in the screen that the door is open, then now is the object is far or non in front on the ultrasonic sensor, the door is closed. For the PC control on this third part of the dashboard is we can control the door directly open without sensing any object in front of ultrasonic sensor. Like this. But this PC control is not our priority of control the door open close. That the priority will be only based on the ultrasonic sensor. So that's all for our hardware simulation.